Hello everyone, my name is Ravindra Yadav and today we are going to discuss one of the most important concept in kinematics, that is called projectile motion. So before studying the projectile motion, we will study about the introduction of projectile, equation of motion of the projectile, and then we will proceed for the next step, that is called next topic, that is solving a projectile motion using the component approach, and then time of flight of projectile and maximum height and range of the projectile. These are the topics which we are going to cover in this section. So motion in one dimension. When velocity and acceleration are parallel or anti-parallel. For example, if a train is moving along a track, then we can say that the motion of train is one dimensional motion, because train either can move in forward direction or it can move in backward direction, but it can't move apart from this track. So we can say that motion of train is one dimensional motion. Or the second, we can say that if velocity and acceleration are anti-parallel or parallel to each other, if acceleration and velocity are parallel to each other or anti-parallel to each other, then what will happen? Then object will move along a straight line. In that case, we can say that the motion of the object is one dimensional motion. For the case of train, if train is moving with constant velocity along a track, then what will happen? It will move only on one axis. But apart from this, suppose we are projecting any object at certain angle, then it will follow a curved path. Now we will discuss about this in next slide. So firstly, we are going to know about we are going to brush up about the equation of motion. So first equation of motion, that is v is equal to u plus at, where v is in final velocity of the object, u is initial velocity, a is the acceleration of the object, and t is time. So these are the three equations of motion which we are going to use in this projectile motion concept. Now for example, if any object is projected at certain angle with horizontal, suppose we are going to project any object at certain angle with horizontal. Let's suppose velocity of the object is u and it is making theta degree angle with x axis or horizontal direction. Then what will happen? It will start to move and follow a curved path. So why it is following curved path? Firstly, we are going to see about the components. So here, acceleration due to gravity, that is vertically downward. There is no force or there is no acceleration along to horizontal direction. So we can say that if we will project the object at certain velocity u, then the component of velocity along the vertical direction is going to change, because here acceleration due to gravity is working in the vertical direction, but along the horizontal direction there is no acceleration. So the velocity along horizontal direction always remain constant. So let's divide the velocity in horizontal and vertical component. This is u and it is making theta angle with x axis. Now we already studied about the division of component. So here, if velocity is u and it is making theta degree with x axis, and component of velocity along x-axis, that is u cos theta, and component of velocity along y-axis, that is u sin theta. Or we can say that velocity along x-axis is u cos theta and velocity along y-axis, that is u sin theta. Acceleration in vertical direction, ay is g and ax, that is 0. So we can say that this is the initial velocity along x-axis, this is initial velocity along y-axis, and this is the acceleration working on the object. Now here we have divided the component ux, that is u cos theta, and uy is u sin theta. Now we are going to find the time of flight of the projectile. So along the horizontal direction, net force on the object, net acceleration on the object, that is 0, but in vertical direction z is working. So we can say that at t is equal to 0, object is on the horizontal ground, and after some certain time, let's suppose after t time interval, object is at certain distance x. It means we can say that the displacement along the horizontal direction after t time, the displacement along the horizontal direction is r, but displacement along the vertical direction, that is 0. Let after t time interval, displacement along vertical direction is 0. After t time interval, the displacement along vertical direction be 0. Why it will be 0? Because object is projected from the ground, and after certain time interval it will again land to the ground. So net vertical displacement is 0. Now using second equation of motion, second equation of motion, is h is equal to uy into t minus half gt square. Net vertical displacement is 0, and uy component of velocity along to vertical direction, that is u sin theta, into t minus 1 by 2 g into t square. Now taking t common, so we can say that u sin theta 0 is equals u sin theta into t, and here we are taking t common, so we can write it as u sin theta minus 1 by 2 g into t and t, because we have taken t common. Now putting the value, first value of t we are getting t is equal to 0, and second value of t that we are getting t is equals 2u sin, here we can write u sin theta minus g into t divided by 2 equals 0. Now after solving this, we will get ct by 2 is equals u sin theta, and after solving this we will get t is equals 2u sin theta upon g. We are getting two value of t. Why we are getting two value of t? Because at t is equal to 0, object was at the ground, and after the second t time interval, object will be again land to the ground. It means we can say that at t is equal to 0, object was on ground, and after t is equal to 2u sin theta upon g, object again will be on the ground. So this is called the time of flight of the object. Why we are calling this as a time of flight of object? Because the time duration under which object was in air, that's why we are saying that this time is a time of flight of the object. So we can from this we can say that time of flight of the object is 2u sin theta upon g. So time of flight of object that is 2u sin theta upon g. Let's solve an example. Here question says that the relation between time of flight t of a projectile which is projected at an angle 53 degree with horizontal velocity u and time to reach the maximum height. So when object was projected at certain angle theta, then component of velocity along x axis, that is u cos theta, and component of velocity along y axis, that is u sin theta. There is no acceleration along the horizontal direction, so we can say that horizontal velocity always remains constant, but here acceleration due to gravity is working along the vertical direction. So what will happen? So it will reduce the vertical component velocity, and after certain time interval its velocity along vertical direction becomes 0. When object will reach at the highest point, then its vertical then the component of velocity along the vertical direction will be 0. Now using first equation of motion, first equation of motion, first equation of motion is v equals u minus g into t. Component of velocity along y direction, initial velocity along y direction, final component of final velocity along y direction minus g into t. At the highest point, the component of velocity becomes 0, and here component of velocity along y direction, initial velocity along y direction, that is u sin 53. Here angle of projection is 53, and we suppose the initial velocity, that is u, so it is u sin 53 minus g times t. Let's suppose this is equation 1, or we can write t equals u sin 53 upon g. Let's suppose this is equation 1. Let's suppose this is equation 1. Now second condition, relation between, we have to find the time relation between time of flight and time when it was at the highest point. So we suppose that the time when it was at highest point is small t, and we know that time of flight of the object t equals 2u sin theta. 2u sin theta is 53 upon g. Let's suppose this is equation 2. Now we can say that u sine theta, and u sine theta upon g, and here it is also u sine theta upon g. Now we can plug this value in equation number 2. Now going to plug the value of t in equation 2. So from this we will get t equals 2 into small t. So this is the relation between time of flight of the projectile and the time at which object was at highest point. So this is the required relation.